Hello friends, this video on aldehyde ketone carboxylic acid part 16 is brought to you by examfear.com. No more fear from exam. So now we'll see reduction to alcohol. We know that we have carboxylic acids. If you reduce, you get ketones and aldehydes. If you reduce further, you get alcohols. And you reduce further, so you get alkenes. So we'll study both. We'll study now from ketones and aldehydes to alcohol and ketones and aldehydes to alkanes. That we'll study in the next slide. Now we'll study ketones and aldehydes to alcohol. So we'll use reducing agent. And reducing agents, we can use NaBH4, we can use LiAlH4, right? Or you can use hydrogen with nickel or platinum. So a lot of things we can use to reduce, right? So with this, for example, I have a aldehyde and I use LiAlH4. What you get is R3H2OH. Or even if you use hydrogen with nickel or platinum catalyst, you get the same thing. Now, what is the reaction mechanism? Let's see the reaction mechanism. Let's try with LiAlH4. So if you see LiAlH4, it is Li plus Al minus or AlH3 plus and H minus. This is how it is actually. The source of H minus ions. That is how it looks. This is the source of H minus ion, LiAlH4, right? You can see the whole thing is plus LiAlH3 and H minus ion. So now if I have RCOH and this is negative, this is slightly positive, this is H minus from this, right? H minus AlH3Li, the whole thing in the positive charge. This will attack this carbon. Correct? So what you get is RCO minus H and you get H here actually, H minus, right? No negative charge here. And on this, any H plus will come and attack. Sorry, it will be attack on this side, this way. O minus will attack H plus. Always from negative to positive attack. And this is what you get. Easy only. Now let's see reduction of aldehydes and ketones to hydrocarbons. As I've just discussed, I have carboxylic acid. You reduce to aldehydes or ketone. You further reduce to alcohol. You further reduce to alkanes. Right? So we'll try this one now. So there are two ways actually to do it. One is Clemmensen reduction and the other is Wolff-Kissner reduction. So let's see the Clemmensen reduction first. In Clemmensen reduction, what we do is we have this aldehydes or ketone. We reflux with zinc amalgam and concentrated acid, preferably HCl. So we have aldehydes. I'm doing the first one, Clemmensen reduction. Aldehyde or ketone. You react with zinc amalgam, correct, and some acid concentrated. So what you get is, so you had COO, it becomes CH2. That's how it is. See, the reaction mechanism is similar to hydrogenation kind of reaction. So what happens, for example, I have RCOR, correct? And I have this zinc metal. This is my zinc, correct? So what happens is, the zinc surface actually, this is zinc surface. Now, flow of electron from zinc to carbonyl compound take place. So we see this carbon is slightly positive, slightly negative, right? So flow of electron will take place from here to here. There will be bond form and this bond will break. Correct. So what will happen now is next step is, so zinc will get a positive charge. There is a bond form. This is O minus R and R. Correct. And since I am using HCl here, some H plus ion will come and will attack here. It will become neutral. So now what will happen is it will form OH. Zinc with still one bond, one positive charge, Cr, R and OH. Since I am using a lot of HCl, again one more H plus will come. So H plus will be attacked where? So oxygen is the only one which has lone pair. So this will attack this H plus. So what will happen now is, again still I am having one positive charge on zinc. There is a one bond here, there is R here, R here, and this will become H2O with a positive charge. Now the heavy molecule H2O with positive charge, so it will have minus water here. It will go off on its own. So what you will get here is carbon with a positive charge and 2R. Right? Now zinc, as I told, has a potential to give electrons, right? So zinc will give one more electron to it. So with this it will form one more bond and this positive charge will go off and zinc will become plus 2 charge. Correct? Because zinc has a potential to give electrons. This is what it will become. Correct? Now again H plus will attack. This is neutral now. Again H plus will attack and the electrons here, right? It's bond here. So this bond will again break and this bond will break in this fashion actually. Right? Now zinc will have 3 positive charge. 1, 2, 3, and this bond will break. Carbon will get a negative charge and negative in charge and this hydrogen will be attacked here. So we will get one H here. Similarly, one more H plus addition. Again this bond will break in this fashion. Zinc will get 4 positive charge. Right? This bond breaks, carbon gets a negative charge and that negative charge, this will be attacked. Negative and positive will form a bond. So what you get here is this. And this is the output. Right? And this is nothing but 2 Zn 2 plus. Right? 2 zinc with 2 positive charge, nothing but zinc with 4 positive charge. So because it's a zinc plate, the zinc surface, there are so many zinc atoms in that. This is the typical process. You use zinc with amalgam and HCl, and HCl is playing the major role and zinc is just providing more and more electrons, right? Because zinc is happy to become Zn plus 2. This is more stable. This we have studied, right? So zinc is, the purpose of zinc is to provide electrons here, and that's what it's doing. It's just providing electrons here. And hydrogen is getting added. So this is the typical reaction mechanism. I have zinc surface. I have this RCOR, this bond breaks, positive charge, and this oxygen gets negative charge. Zinc provides electron to it, forms a bond. Hydrogen attacks this OH. Again, hydrogen attacks this OH minus H2O. Carbon gets a positive charge. Again, zinc provides electrons to this, forms a double bond. Right? Zinc has got 2 double bonds. Zinc has got, there's a double bond between carbon and zinc now, and zinc has got 2 positive charge. Again, H plus attacks, zinc gives one more electron to it. Right? And the hydrogen is added here. Again, H plus attacks, zinc gives one more electron to it. It's added here, and this is free. So you see, this thing has got reduced now. Correct? So this is reduction to hydrocarbon using zinc metal plate and HCl. So we are done with the Clemmensen reduction. Now we'll talk about the Wolff-Kishner reaction. So in this, the carbonyl compound is first converted to hydrazone. hydro zone by reacting with hydrazine. So carbonyl compounds react with hydrazine to form hydrozone, and then it is refluxed with a base, preferably sodium methoxide, at a high temperature. Maybe ethoxide, sodium methoxide, C2H5ONa, at a high temperature, maybe 460 Kelvin. So with this you get CH2, and obviously nitrogen gas also comes out. So this is the typical Wolff-Kirschner reduction. We'll see the mechanism now. First, let me write this overview of this reaction. This reacts with hydrazine, that is NH2NH2. This is my hydrazine, to gives hydrozone, and then it reacts with my base to form CH2 and N2 gas. Now I'll discuss the reaction mechanism. So let's start with this reaction. I have, let's suppose, RCOOR. This is my some ketone, and then I have NH2, NH2 with lone pairs. Correct? As I told, this carbon is slightly positive, slightly negative. So since I'm not adding anything except this NH2, this hydrazine, what will happen is this as lone pair, it will get attracted towards carbon with a positive charge. Correct? So with this, the product that will be formed is, you have C, right? So you get, let's suppose, let me draw like this. O minus, I'm just drawing here, NH2, NH2. Correct? This is what we'll get. This O will become O minus, and this will become NH2, NH2. And since nitrogen has given electrons to this carbon, nitrogen will get a positive charge. Correct? Now let me draw H2 like this to give it a better look and feel. Correct? This nitrogen will get a positive charge. But nitrogen, being electronegative element, will not like positive charge on it. So hydrogen will say, okay, I'll break the bond in this fashion and I'll come out. And this H plus will be attracted by this O minus. Correct? This H plus will come out attracted by this OH, O minus. So what you'll get is R, C, R. This becomes, this becomes OH, and this is N with H, right? And NH2, and again with a lone pair of electrons here. Here also we'll have lone pair of electrons. This is what you'll get. Correct? Again, H plus will attack and take away the water from here. So H plus will attack. This is, it doesn't make sense to attack here, right? Because just it came out from this nitrogen only. Because the moment you attack H plus on this nitrogen, gets a positive charge. It won't like it will again kick the H plus out. So it will go to this oxygen. It will become H2O plus. This is a bulky group, so it will come out. It will come out, and this will be, carbon will get a positive charge because this bond will break. H2O will come out. This is what you will get. Correct? Now what will happen is, this hydrogen will also come out. Nitrogen will get a negative charge, and there if you see, there will be double bond formed because carbon is also not very happy with the double bond with a positive charge, not very happy. So you want to get rid of the positive charge. This alkyl will not go to living group. So this hydrogen will go off in this fashion. In this fashion actually. right? In H plus it will go up because H is a good leaving group. So nitrogen gets a negative charge, negative and positive charge will form a bond. This is what my compound is, hydrozone. So I got this now. Correct. This is what I have got. Once I have got this, I'll use base. What base will do? Base will take out hydrogen. Correct. So let me draw hydrogen in this fashion. Because base has to take hydrogen. So let me draw hydrogen properly here. Yeah, like this. Base will do what? Take out hydrogen. So base can be anything. Example, I have used C2H5O- is the base. So C2H5O- will do what? C2H5O- will come and want hydrogen. Where is the hydrogen? Hydrogen is here in these nitrogens, right? So it will come and take out this, attack on this hydrogen. Correct. Hydrogen goes off, then this nitrogen will get a negative charge. Correct. So let's do that. Nitrogen gets a negative charge and there is a hydrogen here. Correct. Also nitrogen has lone pair of electrons. Now because of resonance, if you see this has lone pair of electrons, these electrons will move in this direction and these will move in this direction, right? So with this what will happen is, see, our job is to put hydrogen here, right? So what will happen is carbon will get negative charge, correct? And this bond will break, actually this bond broke, and nitrogen will get a double bond, and with the H here. That will what will happen. This is what happens because of resonance. This lone pair moves here, it gets double bond. This bond breaks, it moves here. Carbon gets negative charge. Correct? Yes. Now on this, my H plus can attack easily. Correct? So I get H plus here. That is pretty easy. Now I have to remove another hydrogen from here because nitrogen N2 gas can easily come out. If it want to come out also, it is stable. So again I'll have C2H5O- that will attack this hydrogen. So I'm just putting two steps in one because I don't have space to write. So with this what you get is, here you get hydrogen anyway, and the second step, this will attack this H and pull out this H. So it will get a negative charge. Correct? And again nitrogen has a lone pair of electrons. Again because of the resonance, if you see, this charge goes in this fashion, triple bonds, and this bond breaks actually in this way. So with this what you get is R, C, H with a minus charge, and N2 gas comes out. And this minus charge, there is a H plus ion, it will attack here and you get RCH2. So this is the typical reaction mechanism. It is tricky, but it's good to know the reaction mechanism to understand these reactions in a better way. So here first hydrozone is formed and then you use base. Base pulls up this hydrogen from this nitrogen. Nitrogen gas comes out and you get this alkane. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.